Hey guys, it's your math teacher. So on this video, we are gonna continue with 2.4. We did two functions in class, so right now we're gonna pick up or start on function 3 called the square function. Alright, so before we start with the square function, shall I tell you a joke? Okay, here's the joke of today. What would happen if pigs could fly? What would happen if pigs could fly? The price of bacon would go up. Anyway, sorry. I love childhood jokes. What do you know? Okay. The square function, it's going to be f of x. Okay. Remember, that's the same as y, and it can be seen as y equals to x squared. That's a square function. And let's make our input and output chart. Okay. Well, remember, y is the sum of f of x, so we can either use y or we can use f of x. We're going to choose 3 points. Let's choose -2, -1, and 0. So right now, I'm going to give you about 10 seconds to put this in and then give me the outputs, 3 outputs. Okay. Hopefully you got 0 when x is 0, y is also 0. When x is -1, remember it's -1, the entire -1 is being squared, so that should be a positive 1. And -2, the entire -2 is being squared, so you know that's positive 4. So currently get 3 dots. Let's plot those. -2, go up 4. At -1, go up 1. And 0, we're going to stay at 0. Okay. If you remember, y equals x squared is a parabola. So with a parabolic shape, it should be symmetrical. So all we have to do, because it's symmetrical, I'm just going to go to this side and mark the same exact dot as the left. Okay, so instead of -2, 4, I'm just going to go +2, 4. So now with those dots, I will connect them. Okay. Make sure this bottom right here is not a completely pointy shape. It should be rounded out a little bit. Okay, it's not a V, it's more like a U. So that is our parabola. The domain of this, it goes from -infinity to infinity. The range of it, the smallest y value is at 0. Okay. The largest y value, because the arrows indicate that it does go up forever, we're going to go all the way to positive infinity. And we need to put parentheses around the infinity, and we need to put the square bracket around the 0 to indicate that we do include 0 in our range. X-intercept and y-intercept, they happen to be at the same exact location. In this case, it's a point at 0, 0. Now, is it even, odd, or neither? Even means I'm going to be, if I fold it on the y-axis, oh, I should get a thinner pencil. If I fold it on the y-axis, right, the left and the right must be identical. In this case, it is, so we know it is even. Okay. Increasing from this location and up. Okay, so this is your vertex, aka that's your local minimum, or actually, let's answer that question. We do have an absolute. Okay, in this case, it's absolute minimum. So circle that for me. This is the lowest of the lowest. So the absolute minimum is also at its vertex. And an absolute can also be the local minimum. So circle that. Okay. There you go. So that's your local minimum and absolute minimum. They happen to be the same place. We do not have a max, okay, because these go up forever. So there's no max. All right, so increasing and decreasing, it's always going to be separated by either local min or local max, or absolute min or absolute max, okay? So increasing from 0 all the way. So the further I go x direction, the higher the y will go. So increasing from 0 all the way to infinity. Decreasing, okay, so if I keep going to the right, notice how y is decreasing. And we need to write smaller number first, so that's going to be from -infinity to 0. Is it continuous? Hey, can I sketch this out without lifting my pencil? Sure. Start here. All done. Okay. So, yes, it is continuous. So continuous mean, hey, can I sketch it without lifting up my pen or my pencil? That is the square function. Now let's move on to square root. Square root is simply f of x equals square root of x. Okay. This right here has a number 2. This is an index of 2. So let's pick some inputs and some outputs. I'm going to pick nice numbers that we can take a square root of. So let's say 16, 9, 4, and 0. The square root, when I put 16 in, okay, when the input is 16, the output is y is the same as f of x. Remember that? So square root of 16 is 4. The square root of 9 is 3. The square root of 4 is 2. The square root of 0. Is it okay to have a square root of 0? Sure it is. The square root of 0 is 0. Okay. So now I have my inputs, my outputs. Let's plot these out. 16 is way far past my coordinate plane here, so I'm just going to start with 9. So 2, 4, 6, 8, 9. 9 will go up 3. 4 will go up 2. 2, 4, up 2. And 0, say it at 0. Alright, so we're going to go this way, that way, and arrows on this way. Because remember, I can also put 16 over here. Well, can I pick negative 1? Negative 1, can I do square root of negative 1? No, that is not possible. So notice how we're going to stop right here. I can pick 1 if I wanted to, right? The square root of 1 is 1. So technically, I could put 1 right there as well. So this is the square root function. Think of it as your eyebrow, okay? It starts here and it keeps going. Some of us have really long eyebrow that keep on going forever, but it has to start somewhere. All right, so the domain of this, notice how there's no arrow over here, so it starts here. So that is starting at 0, and it goes all the way to the right to keep on going forever. The range, that means we're on the y. There's no negative y. The smallest y value is also at 0. And because this is going up, okay, out and up, so we're going to go all the way to 0 as well. X-intercept and y-intercept, they both cross over at 0, 0, or the origin. Okay. Is this even or odd or neither? It's actually none, neither. Okay. Increasing, it's going to increase the entire time. Okay, increasing the entire time. There's no, if it's increasing the entire time, there's no decreasing, so we can just write none right there. Increasing from 0 all the way to infinity. Absolute min and absolute max, if you know this is the lowest point possible, right? So would you agree that that's going to be an absolute min? So the lowest point is 0, 0, and absolute min is also local min, so that's also 0, 0. Okay. Is it continuous? Can I sketch this entire eyebrow curve without lifting up my pencil? Sure. So it is definitely continuous. If I'm going too fast, please just hit pause and then rewind it to watch it again. Okay. All right, let's move on to number 5. Okay. Cube functions. So f of x equals x to the third. That's what a cubic function is, or a cube function. Let's do our input and output chart. All right, let's put in 0. 0 to the third power is 0. Let's do 1. 1 to the third power is 1. Let's do negative 1. Negative 1 to the third power is negative 1. How about negative 2? Negative 2 to the third power is negative 8. How about positive 2? Positive 2 to the third power is positive 8. All right, we have 5 points. That's plenty. Let's plot those. Here we go. 0, 0. 1, comma 1. Negative 1, negative 1. Negative 2, comma 8, all the way down here. And positive 2, comma positive 8. So it goes all the way up there. Let's connect these dots. All right, looking good, right? Okay, so that is my cubic function, or cube function. So let's talk about the domain. The domain is talking about the x-axis. Do you think do you think this function will eventually go to the right forever? So this is arrow, right? Goes up and out. This is going out and down. So the domain is going to be negative infinity to infinity. The range, that sounds more obvious, down and up forever. So also negative infinity to infinity. X-intercept and y-intercept, they both cross over at the origin. Is it even, odd, or neither? This is an odd function. Okay. All right. Increasing. This looks like it's going down, but it's actually increasing because as I'm going right, notice how y is increasing. So this is increasing from here all the way to here, and then from here all the way to here. So technically it's increasing the entire way, from negative infinity all the way to positive infinity. Decreasing, never, right? If it's increasing the entire way, there's no room for decreasing. Absolute min, local max. Because it's increasing the entire way, there's no such thing of local min and local max or absolute. Okay. And is it continuous? Can I sketch this whole thing out without lifting up my pencil? The answer is yes. All right, so because there's no local min and local max and this special dot right here, it's actually called the inflection point. Okay. And the inflection point is the point where it changes the curvature of the graph. See this right here? Know how this is like kind of curving down and then all of a sudden this is curving up. So that's what the inflection point does. It changes the curvature of the graph. Right now, that's what we're going to call it. Later, we'll go in more detail if we have time. So next one is going to be called the cube root function. Okay. That means we're going to take the third root. That's all it is. F of x equals third root of x. These two are actually inverses of each other. Okay? Okie dokie, here we go. Let's take some inputs and outputs, x and f of x, which is also the same as y. So let's choose 0. Third root of 0 is 0. Let's choose 1. Third root of 1 is, remember, third root means, hey, I need 3 identical things to get it out under the radical. Because it's 1, that means 1 times 1 times 1 is still 1. So therefore, there's 3 identical numbers there. I can pull it out, so that's actually 1. Same thing with negative 1. Third root means, hey, I need 3 identical things under the radical for me to pull it out. To get negative 1 times negative 1 is positive 1. Well, positive 1 times negative 1 is negative 1. So therefore, these two are equals. So that will give me a negative 1. I can pull it out. How about when I have 8? Let's do that. Third root of 8, right? That's what you want to do. 8 means it's 2 times 2 times 2. Would you agree? Well, I got 3 2's, so therefore I can pull one out. How about negative 8? So taking the third root of a negative 8, that is the same thing as saying, hey, negative 2 times negative 2, times -2. So third root of -8 is simply -2. Pretty cool, right? So notice how these two are switching. These were inputs, and we got -8 and +8s were outputs. And now this is our input, and that's our output. See how those are inverse of each other? Inverses means we're going to switch the x and the y, and then y for the x, okay? Let's plot the dots. 0, 0, 1, 1, -1, -1. All right, so this is what I want to bring up. If you have 3 dots, okay, notice how these 3 dots on the top and these 3 dots on the bottom are exactly the same. So if you only have 3 dots, you're going to be confused of how this is supposed to look. So when you have a third root or the cubic function, go further. Okay, give yourself 5 dots, so make sure you're not confused. So we're going to plot 8, go to the right by 8 and go up 2, and -8 and go down -2. So if you have more dots, then you know for sure it doesn't shoot straight up. All right, so these are the dots. So notice how they're switching. Okay, and again, this is your inflection point because it changes the curvature of the graph. All right, the domain. The domain of this, it goes -infinity to +infinity. It's covering all the x's. So -infinity to +infinity. The range is going out and up, so it's going to be -infinity to +infinity again. X-intercept and Y-intercept. Why don't you guys fill those in for me? They're both at 0, 0. Is it even, odd, or neither? Even, odd, or neither? It's definitely odd. Is it increasing at all, anywhere? It's increasing the entire way, right? So if you look at it, the further I go to the right, okay, y is going up. It starts low and it goes up. Starts low and it goes up. So that's how we know it's increasing. So it's increasing from -infinity to infinity. Because it's increasing the entire time, decreasing is none. Absolute min and absolute max, because it's increasing the entire time, there's no such thing. So we're going to write none. And it is continuous because when I sketch it out, I do not have to lift up my pencil. So the answer is yes. Okay. Then the next one. Let me see how many more do we have. We have the absolute value and the reciprocal, and it looks like we have 10 altogether. Okay, so we have 3 more to cover. I highly doubt that I'm going to get to cover all of them in this video, but we'll see how far 25 minutes will take us. Absolute value function. So that will give me f of x equals to absolute value of x. All right, absolute value makes everything positive. So input and output charge. Okay, the chart gives me some inputs. So how about -3, -2, 0, 1, and 4? Just random input numbers, okay? So absolute value of 3 gives me, remember, absolute symbol or absolute value makes everything positive. So once you put it, think of this as shower door, right? You get in the shower door, negative numbers, let's just pretend they're dirty. You get in the shower door, you rinse off, you get out. It's positive because it's clean. -2, get in the shower. Ooh, ooh. Oh, I'm not moving. I'm recording in the classroom. So my light just turned off. That was weird. Okay, wave my hands in the air because I just don't care so my lights can turn back on. Alright, -2, absolute value of that is +2. 0 gets in the shower, scrub off, clean 0. These two are positive numbers. They're clean, so they're going to come out of the shower clean. Okay, so those are my inputs and outputs. So let's plot them. -3, go up 3. -2, go up 2. 0, staying at 0. 1, go up 1. And 4, go up 4, 2, 4, 2, 4. All right. Because these are now straight lines on both sides, so let's find a ruler. Please take out your ID to use a straight edge. Where is my ruler? Ruler, ruler. Oh, here it is. Okay. There you go. Go all the way up on both sides. Okay, there you go. So let's talk about the domain. Notice how it goes right forever and goes left forever. So the domain is negative infinity to positive infinity. The range, it doesn't go down forever, but it does from here all the way up. So we're going to include 0 and to positive infinity. X-intercept and y-intercept, they both cross over at the same exact location, which is 0, 0. Is it even, odd, or neither? It's definitely even for once, right? Is it increasing the entire time, or is it decreasing the entire time, or there's a mixture between the two? If you look at it, it's increasing from here to there. Okay, so from 0 to infinity. And it's decreasing from here, from negative infinity to 0. Do we have an absolute minimum or absolute max? Is it the lowest point that we can see? Yes, the lowest point we do have. The lowest point is at 0, 0. And because we have an absolute min, we also have a local min. Okay. Is it continuous, meaning that, hey, can I sketch this entire curve without lifting up my pencil? And the answer is yes, indeed. Okay. Let me see some lights. There you go. That's slightly better. All right. Again, if this is going too fast, please hit pause. Let's do one more function and we'll call it a day. Okay, so this is called the reciprocal function. So f of x equals, reciprocal means I'm going to flip it. So 1 over x. Okay. So let's input, output, which is the same as y. We're going to try to put in what? What should we put in? How about we put in some really large number, like negative 10. So 1 divided by negative 10 is negative 10. Would you agree? Then how about let's try negative 1. 1 divided by negative 1 is negative 1. Let's try 0. Whoa, what? 0 in the denominator? No way. Not possible. Would you agree? Not possible. So, happy face. How about that? Can we do not possible? Let's do a sad face. Not possible. Ooh, eyelashes. And no. Is that a face? Sorry, my nose was looking too close to my eye. Alright. A mad face. Alright. How about we try negative 1 over 10? What if we do 1 divided by negative 1 over 10? What would that look like? So 1 divided by negative 1 over 10. What are you going to get? Would you agree that it's going to be 1 times negative 10 over 1? Well, 1 times negative 10 over negative 10 over 1 is just simply negative 10. So we're going to plot those, and then we're going to do the positive side. Let's do a wavy line. Let's plot it. Negative 10, negative 10. Oh, dude, I completely screwed this up, didn't I? 1 divided by negative 10 is not negative 10. It's negative 1/10. Oh my goodness. Look at that. So sad. I didn't even do that right. Alright, so here we go. Negative 10, negative 1 over 10th. So super, super close to the x-axis. Negative 1 comma negative 1. Here we go. And when x is negative 1/10, that means it's super close to 0. I get a negative 10. So it looks like this. Okay? This is what it looks like. Do not touch those axes. Okay? It's supposed to be a nice straight one, but I couldn't do. There you go. That's better. That's just the negative side. What if I pick the same numbers but on the positive side? Like positive 5. How about 1 and positive 1/5? Okay. So 1 divided by 5 is 1/5. 1 divided by 1 is 1. 1 divided by 1/5. Okay? When you're dividing fraction, you flip it. So change it to multiplication and you flip. So 1 times 5 over 1 is just going to be 5. So input 5, 2, 4, 5. Then I get a closed number called 1/5, which is positive. 1 comma 1. And when x is 1/5, which is super tiny, right, close to here, I need to go all the way to 5. 2, 4, 5. 2, 4, 5. There you go. I want to make sure I can count. All right. So those are the dots. Notice how none of them is really crossing over or touching the x or y axis. And there's a reason for that, okay? So let's connect these dots. Make sure you don't touch your x or y axis, please. All right. So those are my dots. And those are the... remember, you have to have 3 curves. 3 points per curve. All right. So I'm going to use a different color now. Because x can never ever be 0, class, that's what you're going to do. You're going to give it a thing called an asymptote. Okay? So x, can never be 0. So we use this dashed line to indicate that there is an asymptote going on there. Called an asymptote of x equals to 0. Okay? Because x cannot be 0, this is an asymptote of x equals 0. Also, there's another asymptote on the y. Okay? Because it doesn't matter what value I pick. Negative 100. So let's pick negative 100. 1 divided by negative 100. It's a small number. Negative 1 over 100. But it's still not 0. So notice y could never ever be 0. Y will always, always, always be some number that is not 0. So there's also another asymptote this way. Not cool? Right? There you go. Okay? And we use dashed line. So here's another asymptote. Okay, and we call this line, because it's horizontal, we call this line y equals to 0. Because y can never be it. So the asymptote lines indicate values that x and y cannot be. So that's why we have those. Alright, so let's quickly fill this in before we call it a day. The domain goes from negative infinity to 0, not including. Negative and not including 0, because there's an asymptote there. Union that with 0 all the way to infinity. The range is the same way, negative infinity and stop at 0. Not including 0, so we're going to write it exactly the same way. X-intercept and y-intercept, there are none because they never touch those things. Even or odd or neither, because it is reflecting over the origin. This is an odd function. Is it increasing? So from here to here, notice how y value is decreasing. Okay? From here to here, y value is decreasing. Here to here, y value is decreasing. So this is not increasing, it's decreasing. But it takes a little break. It's decreasing from negative infinity to 0. Okay? And then it decreases again from 0 to infinity. Is it an absolute min and absolute max, a local min and local max? No, there's no such thing because we have arrows on the bottom, we have arrows on the top, and we have arrows on the sides. So none and none. Is it continuous? Can I graph the entire function left and right without lifting up my pencil? And the answer is no. Alright, that concludes our notes for today. Enjoy the rest of your day, and I will see you next time.